So it says write each polynomial in standard form, then classify it by degree and number of terms, then state the end behavior formally, which is what I've started here. So the first thing you want to do is put it in, combine like terms and put it in standard form. So make sure you do this correctly. These are the easiest problems on the test. If you miss these, you're just kicking yourself in the shins. So there's a 5x to the fourth. It's positive 5x to the fourth, no other x to the fourth. I cross them out so I don't miss anything. Do stuff like that on the test to help yourself out. The next thing would be x cubed. There's positive 3x cubed, right? Cross it out, and then minus x. So there's no like terms in this one. So now we'll name it, classify it by degree and number of terms. So you go with the highest degree. So 4, you got to know your names. That's quartic. 4 quarts in a gallon, right? You'd say a quartic. And then there's 1, 2, 3 terms. You've got to do this after you combine like terms. So it's a trinomial. Remember, triangles have 3 points. Make sure you don't confuse degree 3 and say trinomial for degree 3. Degree 3 is cubic, right?
Yeah.
Trinomial is for 3 terms, okay? Quartic trinomial. Okay, so now you'd have to say to yourself the end behavior. Once again, all we have to look at for end behavior is the leading term. So now that it's in standard form, we know it's degree 4, so it's even, correct? So it's either up and up or down and down, right? Up and up. Why? Because it's positive in front, right? So it's a smiley face. Everybody good with that?
Yeah.
So I draw a rough sketch so that I can do this correctly. So I started this for you on the test as x is approaching positive infinity. So as x is going to positive infinity, our function is growing up to positive infinity, right? F of x is approaching positive infinity. And as x is growing to negative infinity, our function is still growing upwards to positive infinity. Everybody good with that one? Okay. Over here, we have an x to the 4x negative 4x to the 5th. There's no like terms with 5th power. The next thing would be degree 2, so plus 2x squared. And then 10 plus 3. Don't unaccidentally say negative 3 because people will sometimes look at this wrong. We look at it from left to right, right? So it's positive 3. So 3 plus 10 is 13. And now we'll classify it by degree and number of terms. So it's 5th degree, so it is quintic. Remember, if you have 5 babies, it's called high quints. So quintic. 3 terms is trinomial. 2 terms would be binomial, right? 1 term is monomial. All you have to know is monomial, binomial, trinomial, and after that, polynomial of 4 terms, and so on. So degree 1, or just a constant with no x, would be a constant, right? Then degree 1 is linear. Degree 2 is quadratic. Degree 3 is cubic. Degree 4, quartic. Degree 5, quintic. And then after that, 6th degree. Okay, so now let's determine end behavior. So the first thing you do is look at the leading, that's all you do is look at the leading term. It's degree 5, so it has opposite end behavior. It's negative, so it's like a negative line. Draw yourself a rough picture. So as x is approaching positive infinity, isn't our function growing downwards?
Yes.
For negative infinity. And as x is growing to negative infinity, as x is growing this way to negative infinity, our function is growing up to positive. Okay, don't mess those up, easiest ones on the test. So there'll be 2 of those on the test, or so 2 or 3. So it says simplify each expression. These are also the easiest ones on the test, as long as you don't make any errors. There actually is some advanced ones on the test. Make sure you don't do something really dumb like multiply when you should be adding or vice versa. Isn't this one addition? Even though there's parentheses, that doesn't mean multiply. It's addition. You're simply combining like terms. Take my suggestion on the test, cross them out so you don't miss anything as you go. So something like this would be 3x squared and 1x squared is 4x squared, right?
Yeah.
So I'm going to cross them out so I don't miss anything. Let's see. 4x plus negative x, that's the same thing as 4x minus x, right? Which is positive 3x's, yeah? Cross them out so you don't miss anything. Positive 10 plus negative 12 is negative 2. Cross them out. I've got everything. Everybody good with addition? That one's an easy one. Subtraction is one where you should be red flagging yourself and saying, I know you're subtracting all that stuff, so I'm going to rewrite it. We're going to have a negative 2x squared because you distribute the negative 1 through. We'll have a minus 2x and a plus 6. It's one of the most missed problems on the test with the easiest stuff, right? right? We're all good?
Yep.
So then make sure you don't like distribute the negative again. You technically made this plus and then you changed all these. Does that make sense? So now you're just adding like terms. So cross them out as you go. We have 3x squared minus 2x squared is positive 1x squared, right? I'm going to not write 1. Cross them out. 7x minus 2x is plus 5x. Negative 8 plus 6 is negative 2. Okay, everybody good with that? Pretty easy. Okay, if you saw something like this, you would double distribute, right?
Yep.
You would multiply x into all of them, not messing up. So draw these in as you go. That's x, like the opposite of what I just did. So you don't miss anything. That's x cubed plus 3x squared. I'm distributing x plus 4x, right?
Yep.
And then negative 2 times x squared is negative 2x squared. Negative 2 times positive 3x is negative 6x. Negative 2 times positive 4 is negative 8. And then you'll add straight down, combine like terms. X cubed, no other x cubes. 3x squared minus 2x squared is 1x squared. So positive 1x squared. 4x minus 6x is negative 2x minus 8. That one's pretty easy. Okay, if you saw something like this is multiplying 3 things. Remember the rule. Whenever you're multiplying 3 things, multiply 2 of them together, combine like terms, and then multiply in the third one. You'll mess up otherwise. So let's do this one, because this is pretty, well, it's going to be a lot of advanced multiplication. X times x is x squared, right? X times positive y is positive xy. Negative y times x is negative xy, right? Same thing as minus yx is the same thing as minus xy, right? Because it's just multiplication. Then right here, do not mess up. Negative y times positive y is negative y squared. Combine like terms before you multiply in this next thing. Don't those middle terms in this one happen to cancel out?
Yes.
So we just have x squared minus y squared. And now we'll multiply in the x squared plus y. Okay, let's do that. Just to make sure we're good. So we're going to start here and distribute. X squared times x squared is x to the 4th. X squared times positive y is positive x squared y. Is everybody good with that? Negative y squared times positive x squared is negative x squared y squared. Does everybody see why? I could put y squared x squared first. Negative y squared times positive y is negative y cubed, right? Everybody good? Combine like terms. Careful though, they have to be the exact same. So in this one, aren't those two not the same as those two? Right, now technically we're supposed to write these in standard form. Remember, this is actually going to be on the test too. If I said to you, what degree is this? You'd say degree, this piece is degree 4, right? Isn't this piece technically, since they're multiplied, degree 3? Okay, and this one's degree 4 and this one's degree 3, correct? So we would reorder this. I mean, these two are technically the same degree, but so let's just write 1 first. And then minus x squared y squared. And then these two are the same degrees, right?
Yeah.
So it doesn't really matter the order on those. X squared y minus y cubed. Now I wrote it in standard form. So just a lot to remember, but you can do it. You got to be really careful with your distribution. Okay. So once again, just a reminder, if you have something like this, x squared y minus y x squared, those are the same, right? X squared y, just making sure. Okay. Okay, so it says the next thing on the test. So that's the front page of the test. If you've got that stuff, you're golden with that. Pretty easy, right? But you got to be careful. So the next one says find the zeros, state the multiplicity of multiple zeros. So isn't it find the zero solving it technically? Yeah. Okay, so if it's already factored, we want to leave it factored, right? We're not going to multiply this out. We have an x. We have x plus 6 twice.
Yeah.
We have 4x plus 5, 4x plus 5, and 4x plus 5, right? Just making sure we all understand that. So it's already factored down to linear factors. So our zeros are 0. Set that equal to 0 and solve algebraically. Subtract 6. Oh, that was a 0, sorry. So we get x is equal to negative 6, right? Negative 6, negative 6. Do your algebra here. Don't do it in your head. You'll probably get it wrong. 4x plus 5 equals 0. You'll subtract 5 first, right? 4x equals negative 5, divide by 4. So x is equal to negative 5 fourths? Yep. So then you would write it to get 100%. Your final answer, which you'd circle down here, is x equals 0, x equals negative 6, with multiplicity of 2, because it happened twice, and x is equal to negative 5 fourths with multiplicity of 3, correct? Mm-hmm. Everybody good with that? Do not start multiplying that out. You're going to end up with a nightmare. First of all, you probably get the multiplication wrong, and then you won't know how to solve it because it's going to be huge. Okay. You'd end up solving it with p over q, but you'll be doing it the whole test. Okay. All right. Okay, sorry, I just wanted to give myself some room. So, okay, so the next one, I had to type this in. So it's really x to the fourth plus x cubed minus 2x squared. It says find the zeros. To find the zeros, don't we need to factor it? We're solving it, right? So in this one, what do we factor out greatest common factor? Okay, good. We'll pull out x squared. You got to write it. Don't just divide by the greatest common factor. That's one of the most common mistakes is people divide it and pretend like it wasn't there. Instead of factoring it out. Now we're dividing by x squared, x squared, x squared. So left in our parentheses right here is an x squared plus x, right? Minus 2. So you'd say to yourself, sweet, now I have a quadratic. I need to keep factoring it. What multiplies to be a times c, what multiplies to be negative 2, and adds up to be 1, 1 times 2, right? Negative 1, positive 2. Can we quick factor it? Now, there's people that like to long factor, and that's fine. You'll come up with the same answer. However, if your a value is positive 1, we know we can quick factor this. We'll just put in our parentheses, put an x in the front, x in the back. Minus 1 plus 2. So then don't forget that there was x squared. Now it's easy to solve. Isn't x squared just x times x, you guys? So think of it like that instead of doing something weird. So we get 0, 0, 1, and negative 2, correct? So we'd say x equals 0 with multiplicity of 2, and x equals 1 and negative 2, correct? Everybody good? Okay, that should be an easy part of the test. Sorry this is fuzzy, I had to blow these up pretty big. So it says solve each equation. So then the next part of the test, probably the biggest portion worth the most, is being able to solve, and it's just all it's going to say is solve each equation. You're going to look at the problem and say, how do I solve it? Good. So the first thing, yes, get it in standard form. So we need it equal to 0, subtract 3x. So we have 2x cubed minus 5x squared minus 3x equals 0. That's our first step. Good. Greatest common factor. You're going to have one of each type, basically. Do you see how we would solve this one by GCF? So you factor out an x, and then remember your goal is to get it down to quadratic and linear factors. So we factor out an x, now divide by x, but don't just divide by x and pretend like x wasn't there. So we have 2x squared minus 5x minus 3. Now it's linear quadratic, right? So we'd say, can we factor this piece? So let's do it. What multiplies to be negative 6? Look, a times c, and adds up to be negative 5. 1 and 6, negative 6, right? Uh-oh. Can we quick factor it? Nope, so we've got to drop and break. So drop, 2x squared, drop down negative 3, break down the middle term as those two factors. Order doesn't matter. I'm just going to just go with 1 first, so plus 1x, right? Minus 6x. Now we're factoring by grouping. In common here is x, right? Left is 2x plus 1, yeah? In common here is negative 3. Divide by negative 3, divide by negative 3. Won't that be positive 2x plus 1? It did factor because our safe haven is the same. So we're factoring out 2x plus 1. Left is x minus 3, right? And then you can't forget x. So now we'll set each of those equal to 0 and solve. Now, you should use your fundamental theorem of algebra, and how many solutions should we have? 3. So when we get, you guys tell me what those are while I gap him his. So you got, make sure you don't, if it would be worth it on the test to just literally set those equal to 0 and algebraically solve. So we get negative 1/2 and 3. 0, negative 1/2, and 3. Everybody good? Yeah. Okay, next one. In the same section, solve each equation. It's already set equal to 0. How would you approach this one trying it? Grouping. We have 1, 2, 3, 4 terms, so we should try factoring by grouping. If it works, then that's the best method. So what do we factor out? X squared. X plus 2, in common here is positive 5. Left is x plus 2. So it did factor by grouping, right? But we're not done. Factor out x plus 2, and left is x squared plus 5, right? Linear quadratic, set each of them equal to 0. Solve for x using the correct algebra. So we'll get x is equal to negative 2. Do the algebra here. Subtract 5. X squared is equal to negative 5. X is equal to, what would it simplify to be? Good. Okay, let's count how many solutions. 1, 2, 3. We should have had 3. We're good. Okay, awesome. So we've done now one by grouping. We've done GCF. Do you see how there's going to be one of every type? Okay, next one. Solve each equation. First, we need it equal to 0. X to the 4th minus 3x squared minus 4 equals 0. How would you solve this one? Yep, so we're going to say, let x squared equal u. You guys are better at solving these than my honors kids. So we have u squared minus 3u minus 4, correct, everybody? Now we solve u substitution by factoring, right? 1 multiplies to be negative 4, adds up to be negative 3, 1 times 4, negative 4. Can I quick factor this quadratic? If not, we drop and break. That's really important. Remember that, right? Everybody? So this will be u plus 1, u minus 4. A lot of people mess up on this one because they get too ahead of themselves, too sure of themselves. So u plus 1 equals 0. U minus 4 equals 0. So when we get u equals negative 1. When we get u equals 4. So then we've got to say x squared equals negative 1. X squared equals 4. Solve for x. Square root. So we get x is equal to plus or minus I. And then, there's square root of 1 is 1, right? So 1 times I is just I. Okay, square root, x is equal to, okay, let's check. 1, 2, 3, 4, it's degree 4, we've got them all. Okay, good, you guys were recognizing these right off the bat, so that's good. Solve each equation. So I gave you 2 examples of this, and we'll factor the one, solve the other one. So first of all, it says solve each equation. We have x cubed equals 1. Would I just cube root both sides? No, that would be bad. That's like what 90% of my honors kids did, and all 90% missed it. So what should we do? Get it equal to 0, right? So we have x cubed minus 1 equals 0. Now, isn't this 2 perfect cubes? So that's when we factor it using our trick. Front with the front with the back with the back. So you have to know what the front thing is. You take the cube root of the front thing, you get x. Cube root of the back thing, you get 1. Not including the signs, right? I developed a cough over the weekend. Okay, so we put in our parentheses. Now our thing starts. Front with the front would be x times x, which is x squared. Front with the back would be 1x. Back with the back would be 1 times 1, which is 1. Now we'll put in our signs. This sign's the same as that sign. The next sign's opposite. The next sign's always plus. Now why don't we just set each of those equal to 0 and solve? So we're going to get x equals 1, and then we would do quadratic formula for this piece, because it doesn't factor, and we'd go through the process. Do you want to do this one? I was thinking we'd maybe do this one instead, all the way through, if that's okay. So we have 8x cubed minus 1 equals 0. Once again, you've got to recognize this is 2 perfect cubes. 8, the cube root of 8 is 2. The cube root of x cubed is x. So does everybody understand how the front's 2x? The back thing's 1. Now you'll start your thing. Front with the front, make sure you multiply, don't add them. Front with the front is 2x times 2x, which is 4x squared. The front with the back would be 2x times 1. Back with the back is 1. And now this sign's the same as that sign. This sign's always opposite. This sign's always plus. So now we'll have 2x minus 1 equals 0. So when we get x is equal to positive 1/2. Yeah. Yeah, front with the back. So that is 2x times 1. Front with the front with the back with the back. Yeah. Now we'll quadratic formula the heck out of this guy. So x equals negative 2 plus or minus. You need to be excellent at this. B squared So 2 squared minus 4 times a times c all over 2 times a. So we would go x equals -2 plus or minus the square root. We know that we've stressed this so much, only type in that part.
I got -12.
That's right, -12 all over 8. Then we go off, we never divide those right now, do we? We go off to the side, simplify -12. 4 times 3, 2 and 2. 2i square roots of 3, right? So x is equal to -2 plus or minus 2i square roots of 3 all over 8. All of them divided by 2. Make sure that that doesn't disappear. That's what tends to happen. People have this front thing disappear. This becomes a 4, a 1, and a 1. So we have x is equal to -1 plus or minus 1i square root of 3 all over 4. We have 1, 2, 3 solutions. It was degree 3.
Yay.
Probably the hardest one only because simplification and everything's involved. But really, you guys, I feel like we should do that for this. Okay, looking at this one, I would solve this one by trying. What would you try first? Let's try grouping first. Okay, I'll show you what will happen. So we factor out x squared. Left is x minus 1, right? Factor out -3. Left is x plus 3. Safe haven's not the same. So we'd say, okay, this must be the one where we're solving by p over q, right? Okay, we've got it. So remember, q is the leading term, p is this. Q is the first one, and then p is the second one. Okay, so we're going to do factors of p, which is plus or minus 1, plus or minus 3, plus or minus 9. Q is plus or minus 1. So possible P over Q's are plus or minus 1, plus or minus 3, plus or minus 9, right? So now you will graph it on your graphing calculator. I'm letting you guys kind of cheat. See where it looks like it's crossing the x-axis at a whole number place. We'll test it though. Where does it look like it's crossing? 3? Positive 3? Okay, let's test that. So we're going to put in 3. Coefficients 1. Now careful here, make sure you're not missing anything. In this one, we're not. But you might be on the test, you might not be. You know what I mean by missing one? Like if that was gone, you have to put in a 0. So we have 1, -1, -3, -9. You drop this straight down. A lot of people mess up on this. You put a 1 right there, right? Or whatever that is. Now 1 times 3 is 3. We add straight down and get 2. 2 times 3 is 6. We add straight down and get okay, this is where people mess up too. They'll like say negatives and weird things. 3 times 3 is 9. We add straight down and get 0. So we'd say the remainder is 0. So we know that x equals 3 is truly a solution. There's one of them. We need to find 2 more solutions, correct? Didn't we go from degree 3? We divided it once. Now it's degree 2. So we have x squared plus 2x plus 3. So we could solve this one. We could try by factoring. Let's see that. Let's see.
Why are all of the over
they're plus and minus because we're looking at either or factors. Because it could have been a negative. Like, look, if the factors could have been -1 times +9, that would be -9, if that makes sense. And then +3 times -3 would be -9. So do you see what the -9 could have come from anywhere? Does that make sense? Okay, so it multiplies to be 3 and adds up to be 2. Don't accidentally do this backwards. People will do what multiplies to be 2 and adds up to be 3, and then it would factor, and you'll get it wrong. You see what I mean? This doesn't factor, because look, 1 times 3, that has to be negative, right? That's not -3. We all see how this does not factor. So we'd say, okay, that's fine. It doesn't factor, so these must be imaginary or irrational. Now, aren't we solving for any solutions right now? We got to keep going. Does everybody see what I'm saying? Quadratic formula, x equals -2 plus or minus the square root, 2 squared minus 4 times 1 times 3, all over 2 times a, so 2. X is equal to -2 plus or minus the square root, 4 minus 12. Yep. -8 all over 2. We would never divide those, would we? That'd be getting too ahead of yourself. So you simplify -8. 4 times 2, 2 and 2. So 2i square roots of 2, right? So x is equal to negative 2 plus or minus 2I square root of 2 all over 2. Now this is where a lot of people make their errors. So they'll say, oh, the 2's divide out, so we're just left with this. That's wrong. 1, that's 1, 1. That plus or minus makes it x is equal to negative 1 plus or minus I square root of 2, right? 1, 2, and then our other solution was x equals 3, right? It was degree 3, so we found them all. So we've solved by every method now. So you'll say, I aced that part of the test, the hardest part. Okay, next thing it says, write a polynomial function with rational coefficients so that p of x equals 0 has these given roots. So these are the given zeros. I'm going to split it up and go backwards, right?
Yeah.
So we'll add 1 to get it equal to 0, right? Everybody good?
Yeah.
So then we'll add 2, so we'll have x plus 2 equals 0, and so on, right? So I'm going to skip because we don't have that much time. We have an x plus 1 times x plus 2 times x plus 3 times x plus 4, right? We would multiply those two together, then multiply those two together, then multiply all of it, right? If there was 3 of them, wouldn't we multiply 2 of them together, then multiply the third one?
Yeah.
Okay, let's do this one. So we know x is equal to 4i, so x is also equal to what? Negative 4i, and then we have x is equal to negative 2. That's conjugate is not a root. So going backwards, won't this become x minus 4i times x plus 4i, right? Times x plus 2. Multiply those two together first, right? Everybody? Okay. If your answers come out with i's in the end, you've done something wrong in your simplification. They're going to come out perfect polynomials. Does that make sense? Yes. So let's quickly do this one. We're going to have an x squared plus 4ix minus 4ix minus 16i squared. A lot of people mess up and just say 4i squared. Does everybody see why it's 16?
Yeah.
And why it's negative 16i squared? So then the middle terms cancel out because those are conjugates, right? So we have x squared minus 16i squared. So isn't that x squared plus 16? Because we know that that's negative 1 times negative 16, right?
Yeah.
Everybody good? And now we would multiply that through to x plus 2. So I'm going to say that again. You see how there's no i's? Everybody? That's going to be true. If you have i's in your answer, you've done something wrong in the simplification. Everybody good? I'm not going to keep going. Okay, next one. It says divide using synthetic division. So we would use negative 5 for synthetic, right? You use the 0, subtract 5. Opposite. Then you put a 4 in, a 23, and a negative 16. Drop down 4. 4 times negative 5 is negative 20. Add 3 down 3. 3 times negative 5, negative 15. We get negative 31. So that's our remainder, right? Now work backwards. Remainder, constant, then x, which makes sense. Didn't we take an x squared and divide by x, which would leave us with x, right? So we have 4x plus 3 with our remainder. So you'll say minus 31 over x plus 5. That's the polynomial we get. Divide this one using long division. So we put x minus 5 on the outside. We put in x cubed minus 3x squared minus 5x minus 25. So we go off to the side and focus on the leading terms.
Yeah.
X cubed divided by x is x squared. That comes up here. Then we multiply it back down. So x cubed, right? Minus 5x squared, right? The most missed thing on the test is changing the sign on both of those. Now we add straight down. 0, that's positive 2x squared, right? We still have our minus 5x, and we still have minus 25, right? Now we start over. You see how it's just starting over the process. We go off to the side and focus on the leading term, 2x squared divided by that leading term x, which is 2x, yeah? Positive 2x, so we say plus 2x. Then we'll multiply it back down, so that's positive 2x squared minus 10x, right, everybody? Most important part is changing the sign. Change the sign, change the sign. We add straight down. 0, that's positive 5x, right? You mess up on one little thing, your whole thing's wrong. And then minus 25. Now we're back to the start again, because that's what's left underneath. So we're doing positive 5x divided by x, which is positive 5. So we have plus 5, then we multiply it back down. So that's 5x minus 25. Change the sign. Change the sign. We actually don't know, we happen to get a remainder of 0. Okay, awesome. So my question is, was that a factor? Yeah, because remainder is 0. If not, you'd say no. So this would be our answer, right? Okay. Use the rational root theorem to list out all possible rational roots, then find any actual rational roots. So this is P over Q, right?
Yeah.
So this is the same thing. You would do P over Q. Do I need to go through it? I don't know if we're going to have time. This is Q. Maybe we should talk about this one. Factors of P plus or minus 1. There's a lot. 2, 3, 4, 6, and 12. And then Q is plus or minus 1, plus or minus 2, right? Do all P over Q's, list out P over Q. That would be possible, right? Then actual, wouldn't we just put it in our calculator and then test it using synthetic division, everybody? Now I look for whole numbers. Okay, here's the thing. So you'll look for whole numbers, and let's say we find one. Like let's say that we find 4. We'll do synthetic division with 4, and then won't it go from a degree 3 to a degree 2? Once it's at degree 2, if it's factorable, then there are 2 more rational roots. Does everybody understand? You'll solve the other 2 by factoring. If it doesn't factor, there are no other rational roots because they'll be imaginary or irrational. Does everybody understand? Okay, so you would only have 1 rational root. You don't need to solve all of them. Does everybody understand the difference between this and the other problem?
Yeah.
Okay, last thing on the test is this. So given a table, you'll have to go and put in the correct list into list 1, into list 2, and then calculate it. Then it will ask you to model the cheese consumption for a different year or whatever it is for a different year. You'd have to get the correct X value for that, right? And you just plug it in. Make sure, here's the important thing. Look at right here. Do you see the E to the negative 5? You got to move the decimal. Do you see how this is what it looks like? You got to write it out as a decimal. Look. Yep. Okay. Okay. That's it. Yep.